Which of the following functions of time represent a. Simple harmonic, b. Periodic but not simple harmonic, and c. Non-periodic motion? Give period for each case of periodic motion. Let us first take y equals sine omega t plus cos omega t. Let y equals sine omega t plus cos omega t equals square root 2, 1 upon square root 2 sine omega t plus 1 upon square root 2 cos omega t equals square root 2 sine omega t cos pi upon 4 plus cos omega t sine omega t equals square root 2 sine omega t plus pi upon 4. Since sine omega t plus cos omega t can be expressed as y equals r sine omega t plus phi. Hence as SHM, periodicity is 2 pi upon t. Taking the next question. E. Sine omega t plus cos 2 omega t plus sine 4 omega t. Let the time period as t equal to sine 2 pi upon tt plus cos 2.2 pi upon tt plus sine 4.2 pi upon tt equal to sine 2 pi upon tt plus cos 2 pi upon 2 t plus sine 2 pi upon 4 t. Clearly we have three waves having time period t, t upon 2, t upon 4, and since it can't be expressed as r sine omega t plus phi, therefore motion is periodic but not SHM. E. Next y equals sine cubed omega t. Here we use sine 3 omega t equals 3 sine omega t minus 4 sine cubed omega t. Therefore, sine cubed omega t equals 1 upon 4, 3 sine omega t minus sine 3 omega t. Two waves involved in it are periodic but since can't be expressed as r sine omega t plus phi, therefore not SHM. IVY equals 3 cos pi upon 4 minus 2 omega t equals 3 cos minus 2 omega t minus pi upon 4 equals 3 cos 2 omega t minus pi upon 4, which is of the type RCOS omega t plus phi. Hence periodic in SHM. The displacement of a particle varies with time according to the relation y equals a sin omega t plus b cos omega t. The motion is oscillatory but not SHM. B. The motion is SHM with amplitude a plus b. C. The motion is SHM with amplitude a squared plus b squared. D. The motion is SHM with amplitude a squared plus b squared. Dot. Y equals a sine omega t plus b cos omega t. A equals r cos phi and b equals r sine phi. Y equals r sine omega t dot cos phi plus cos omega t sine phi. Y equals r sine omega t plus phi, where r squared cos squared phi plus sine squared phi equals a squared plus b squared. That is, r squared equals a squared plus b squared. Therefore, r equals square root a squared plus b squared. A particle is acted simultaneously by mutually perpendicular simple harmonic motions. X equals a cos omega t and y equals a sine omega t. The trajectory of motion of the particle will be a. An ellipse, b. A parabola, c. A circle, d. A straight line. Given x equals a cos omega t and y equals a sine omega t, squaring and added, x squared plus y squared equals a squared cos squared omega t plus sine squared omega t. Therefore, x squared plus y squared equals a squared, which is a circle. Indicate the initial t equals 0 position of the particle doing SHM. Find the radius of the circle and the angular speed of the rotating particle. X equals minus 2 sine 3t plus pi 3. Given x equals minus 2 sine 3t plus pi 3 equals 2 sine 3t plus pi 3 equals 2 cos pi 2 plus 3t plus pi 3. X equals 2 cos 3t plus 5 pi 6. Comparing with x equals r cos omega t plus phi, we get r equals 2 omega equals 3 phi equals 5 pi 6 equals 150 degrees. Therefore, by differentiating, dx upon dt equals minus 2 cos 3t plus pi 3.3. V equals minus 6 cos 3t plus pi 3. At t equals 0, v equals minus 6 cos pi 3. V equals minus 3. Therefore, omega equals v, r equals minus 3, minus 2 equals 1.5 radians per second.